Assalamualaikum students. Students, in today's class, we are going to study and to discuss the construction of half cells and the construction of full cells. Now, construction of half cells under standard condition. You know what are the standard conditions? The standard conditions are 25 degrees Celsius, 1 atmospheric pressure for any gas that is used, and 1 mole per dm cube is the concentration of ions. It's actually for ions most of the time. Now, when we construct the half cells, we say that half cells are of 3 types. How they are of 3 types? Look, first, metal and its ions. Second, ions having different oxidation state. And third, non-metal and its ions. Non-metal and its ions. Look, if I share the data booklet with you people, look. See? This is not the complete data booklet. I've just copied some of them. Look. Is this metal and its ion? Yes. So this is the first case. Metal and its ion, metal and its ion, metal and its ion. What about this? Non-metal and its ion? Now next, this is again metal and its ion. Again, non-metal and its ions, non-metal and its ions. And this we can say, ions having different oxidation state, metal and ion. But this is what? Ions having different oxidation states. And this is metal and ions, metal and ions, metal and ions, ions having like the whole, these are divided into 3 situations so that we can construct them easily. Now what you are supposed to do, the first case. Metal and its ions. Metal and its ions. This is the container, the beaker. Inside the beaker, there is the solution of ion, aqueous. Its concentration is 1 mole per dm cube. And the metal is itself the electrode. Metal is itself electrode. This is the half cell. This is working at 298 Kelvin. For example, this is Al3 plus gain 3 electron. Aluminium, this is half cell, right? So how you're supposed to construct it? Look, what I'm going to do, I'm just copying the same thing and only changing. Listen. Oh, what I did. This is what? Aluminium. This is aluminium ion aqueous. 1 mole per dm cube. That's it. So, if they ask me to draw it for, suppose, cobalt 2 plus, gain 2 electron, cobalt, Huh? How you will draw this? This is the container. This is the cobalt metal itself electrode. And this is cobalt 2 plus aqueous. Cobalt 2 plus aqueous 1 mole per dm cube and 298 Kelvin. So what you will use to provide cobalt ions? Any salt. Cobalt chloride, cobalt nitrate, aluminium nitrate. Like you can use any salt to provide the ions of that thing. Right? So, and you have to ensure that the ions must be 1 mole per dm cube. The metal is itself the electrode for any metal and its ions. Like this is Fe2 plus gain 2 electron Fe. So, this is your container in which there are the iron 2 ions using iron 2 chloride, iron 2 sulfate, 1 mole per dm cube, and the electrode is what? Fe, and the temperature is 298 Kelvin. What is the second case? The second case is what? Huh? Ions having different oxidation states. For example, iron 3 gain electron, iron 2. There is no metal, no metal. So we use platinum electrode. Why platinum? If there is no metal, you will use platinum or graphite even, right? But most of the time they write platinum. Platinum is like very sophisticated. Even in the measurement process, they use platinum. They don't use graphite. But you can use graphite equally because it's also unreactive. Why we use platinum? It's unreactive and it conducts electricity. It will not interfere and it will do its job. Okay. So how you are going to construct the half cell? There is no metal. There is no metal. So what am I supposed to do? The platinum is the electrode and there are iron 2 ions aqueous. 1 mole per dm cube. Iron 3 aqueous. 1 mole per dm cube. Like each ion is 1 mole per dm cube. Its concentration and 298 Kelvin. Another example. Look, this is iron 3, iron 2, each is 1 mole per dm cube, and there is no metal. These are ions, these are not metals, these are ions. So if there is no metal, what you are supposed to use? Platinum, right? Now, suppose if they ask you to draw MnO4, 8H plus 5 electron, Mn2 plus 4 water, this is a half cell. Is there any metal? No. Metal, 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 no metal. So what you're supposed to use? Platinum. Your electrode is what? Platinum. And containers, there is this platinum. In this container, there is MnO4 aqueous. There is H plus aqueous. There is Mn2 plus aqueous. And you know, each is 1 mole per dm cube, 1 mole per dm cube, 1 mole per dm cube, and 298 Kelvin. Right? So if there are ions, you will write the ions and you will use platinum. But if there is a metal, then the metal is itself the electrode. The metal is itself electrode. itself electrode. Okay, now the third case, non-metal and its ions. What? The third case is what? Non-metal and its ions. Okay, your non-metal, your non-metal could be gas, could be liquid, and could be solid. But in the past papers I've seen, they only ask for the gases. Like I have never seen that they ask you the construction of the liquid or solid. But okay, we can do one example of each. For example, you have iodine, which is solid, plus two electron, making two iodide. So what are you supposed to do? Is there any metal in this? No. So what should be the electrode? Again, platinum. Huh? The electrode is what? Platinum, because there is no metal. So it's what? Platinum. Done. And there are definitely iodide ions. And they are what? 1 mole per dm cube. If I will add iodine into this, some of iodine will dissolve and some will settle at the bottom. The iodine will settle. This is iodine solid. And must remember that your platinum must be in contact of both iodine solid and iodide aqueous. Okay. Second example. Not second example, second case, you can say. The bromine liquid. It is liquid at room temperature. To bromide. So what you are supposed to do? This is your beaker. Huh? The beaker contain, definitely the electrode is platinum because there is no metal. There is this bromide ion aqueous. The ions are always 1 mole per dm cube, and there is bromine in that solution. This is bromine water, bromine liquid. You can write liquid, you can write aqueous. We know it's not very miscible. It's not fully going to dissolve because this is non-polar and water is polar. So they're going to be like, we have to mix them together. And this is in contact of both, right? Now, if there is a gas, and we don't write even concentration for bromine, right? The concentration 1 mole per dm cube is only for ions, right? Now, if there is a gas, there are too many questions on the gas. For example, 2H plus gain 2 electron, H2. You know, it is the standard hydrogen electrode. The standard hydrogen electrode. You know, all these E naught values, all these values are measured. These values are measured relative to what? Standard hydrogen electrode. And what is that standard hydrogen electrode? It's simple, not something special. It's just normal electrode that they have used for the comparison. Like what they did, they give the value, they give zero potential to this, which is not the actual case. Like they made it zero. They made it zero and they compare all the other with this one. So if I draw this is my beaker, containing H plus ions. Yes. How much? 1 mole per dm cube, right? What should be the electrode? Definitely platinum. Platinum. And what you will do for this gas, you will bring this gas at 1 atmosphere pressure and you have to dissolve it in. So you will use some closed container. You will use closed container to bring hydrogen. So what we are supposed to do? We will use glass bell. Now, if you're going to touch it, close it here, inside this pressure will build. So what you are supposed to do? You have two options. Look, I'm drawing. Wait a minute. You have two options. Either, this is a closed container called glass bell. This is hydrogen gas. At how much pressure? 1 atmosphere pressure coming inside. And what you will do? You will make these slits, right? So that extra gas can go out. Pressure will not build, right? Like the hydrogen gas coming, if the reaction is complete and if hydrogen is more or it is formed, maybe hydrogen is formed. So there must be space so that the gas can go out. Or what is the other easy way? Listen, just make it and don't touch the bottom of the beaker. That's it. Finish. Like leave this space so that the gas can go out if it is in excess. The hydrogen gas at how much pressure? 1 atmospheric pressure is coming inside. It's platinum. So this is hydrogen gas. This hydrogen ion. They're in contact of the platinum. The reaction will occur depending on the other half cell. This is just one half cell. One half cell. One half cell. Right? We are drawing half cell. Now, if I ask you that how you will draw for chlorine, gain 2 electron, 2 chloride. This is your container. This is your container. And this is platinum. This is chloride. Aqueous 1 mole per dm cube. I'm not touching it down to the beaker. This is chlorine gas, 1 atmospheric pressure. This is platinum, 298 Kelvin. 298 Kelvin. That's it. Like even if it is for fluorine, it's exactly the same. Fluorine, any gas, the gas will come down. There is this platinum and ions. That's it. And now next, construction of an electrochemical cell. A full cell. A full cell contains what? 2 half cells are connected by salt bridge connecting wires, volt meter, salt bridge, complete the circuit by movement of ions. Connecting wires, charge carried by delocalized electron, and voltmeter measures E cell. E cell, the potential difference of 2 half cells. Now, how you will construct? Okay, we are also constructing this under standard condition. Under standard conditions. For example, in the paper they ask that MnO4 8H plus 5 electron, Mn2 plus 4 watt, 1.52 volt. This is one half cell. And chlorine gain 2 electron, 2Cl negative, 1.36 volt. These are two half cells, and these two half cells are connected by what? Salt bridge, connecting wires and voltmeter. How you will construct it? Come. This is another half cell. Okay. This is I'm drawing this for MnO4. This is platinum. These are ions, ions, ions. So what you will do? MnO4. Aqueous. You have to draw everything, everything. Write, label everything. MnO4, 1 mole palladium cube. H plus aqueous. 1 mole palladium cube. Mn2 plus aqueous. 1 mole palladium cube. This is one half cell. The other half cell is having chlorine gas. So what you are supposed to do? The glass bell. This is again platinum. And there is this chloride aqueous. 1 mole palladium cube. And this is the closed container, the glass bell. And what is coming? Chlorine gas at 1 atmospheric pressure. Right? So, this is the chlorine, chloride, and this is the manganate. The two half cells are connected. The two half cells are connected by voltmeter, which measure what? The E cell, the potential difference between the two half cells. Potential difference between two half cell is measured. Then there is this salt bridge. Look. Inverted U-shaped U. This is salt bridge. You know, inside the salt bridge are potassium and the nitrate. This is salt bridge. These ions move, but these ions don't interfere. They're highly unreactive. They can't precipitate anything. Can't precipitate anything. Like they use potassium nitrate because if the nitrate is coming here or potassium is coming here or they're going there, they're not going to precipitate, they're not going to interfere, nothing will happen. They just complete the circuit by movement of ions. This is salt bridge. This is voltmeter connecting wire. These are two half cells. How this half cell will work? Your next question. Your construction is complete. How it will work? Which one gain electron? Which one lose electron? Where the electron go and which one is positive? Which one is negative? What is the overall equation? And what is your observation? Now, look. If you look at your full cell, this can gain and this can also gain. These two can gain. They can gain and they can gain. So the manganate can gain and the chlorine gas can also gain. On this side, there is a gain, there's a species that can gain and there is a species that can gain. But among these two, which one is going to gain? The one with a large E naught. So which one has large E0? Huh? The manganate 1.52 is large. So this one is gaining electron. So which one is going to gain? MnO4 will gain. MnO4 will gain electron. Look, the MnO4 will gain, making into what? Mn2 plus. When the MnO4 gain, it will decrease. And the solution will change from purple to colorless. Like in this beaker, the MnO4 can gain electron. Their tendency to gain is more than the chlorine. So definitely, if they are gaining electron, they become Mn2 plus. It's going in the forward direction. This reaction is going in the forward direction. So in this half cell, the solution which was purple initially due to manganate will turn colorless because the Mn2 plus is colorless. Right? Now next. If this one is gaining electron, definitely which one is losing electron among these two? The one with the low E0. So if this is losing electron, this one is losing electron. So chloride is becoming, Chloride is becoming what? Chlorine. Am I right? The chloride is losing electron. So they are losing electron and they become chlorine. So what you will see, when the chloride is becoming chlorine, you will see green-yellow bubbles coming out. You will see effervescence. Like I agree, gas is coming here, but more gas is formed. You can see. So you will see bubbles. You will see green-yellow gas coming out. Perfect. So this side is losing electron and they are gaining electron. So they are losing and they are gaining. So what is the direction of electron flow? Electrons are negative. Keep in mind. They move to positive half cell. So this clear cut shows if electrons are going this way, so if the electrons are coming this way, this one is positive half cell. And this one is negative half cell. Positive half cell and negative half cell, right? So you know the direction, you know the positive and negative, you know that it's gaining, is losing. Now the last thing, I'm going to construct the equation and the E cell. So this one is going in the forward, this one is going in the backward. MnO4 plus 8H plus 5 electron. So one thing I think we should do before writing this equation. This one is gaining 5 and this one is losing 2. So what you are supposed to do, multiply this whole with the 2 and multiply this whole with 5. So what am I supposed to do? What I'm doing? 8. 2 MnO4 to 8 the 16H plus to 5 the 10 electron. 2Mn2 plus. To 4 the 8H2O. And I told you that E0 are not, the volts are not multiplied because the volts is a ratio of what? Coulombs to joules, they remain the same. And this one is flipped. This one is flipped. Multiplied by 5, so 10 chloride. Losing 10 electron. And 5Cl2. And its sign is flipped. So what is the overall equation? The overall equation, the electrons are cancelled. 2MnO4 plus 16H plus 10 chloride. 2Mn2 plus 8 water, 5Cl2. And if I take the sum is what? E cell. How much is the E cell? It is 12 minus 6 is 6. And 4 minus 3 is how much? 4 minus 3 is 1. So it is plus 0.16 is the potential difference of the two half cells. Can we calculate? Look, can we calculate delta G? This was the last time. Like if the E cell is positive, the reaction is visible. From the E cell, can I calculate the delta G? Of course. How? I know the E cell for that. So the delta G is what I'm doing just for practice, okay? Delta G is equal to minus N. What is N? The electron transfer, 10. It's gaining 10, it's losing 10. So how much electron transfer? 10. 10 into 9. NF E cell. F is what? 96500 coulomb constant. And E cell is 0.16 divided by 1000, and you will get your answer. And your delta G is negative, spontaneous, visible. Now, yes. See what is written? The question number 2. Draw a fully labeled diagram for the apparatus. Like they are just asking for the diagram. So, look, draw a fully labeled diagram of the standard hydrogen electrode. That I did right now. And now, another, draw a fully labeled diagram of the apparatus you could use to measure the E cell of the cell composed of this and this. Now, this one is what? There is no metal, so platinum and Fe3 plus aqueous. Fe2 plus aqueous. 1 mole per dm cube. 1 mole per dm cube. What is the other half cell? It's copper. In copper 2 plus aqueous. 1 mole per dm cube. And this is what? Voltmeter. And this is salt bridge. See, this is salt bridge. And 298 temperature. Now, if you want to see that which one is going to gain and which one is going to lose, you need to know their E0 values. You know what are the E0 values? Fe3 plus gain electron, making what? Fe2 plus 0.77 volt. And copper 2 plus gain 2 electron, copper plus 0.34 volt. So these two can gain electron and these two can lose electron. These will gain electron and lose electron. Which one is going to gain? The one with the large E0. So which one? This is large. This will gain and copper will lose. So iron 3 will gain. Listen. Iron 3 will gain. This will gain. And it will lose, dissolve. The copper, it will lose electron. It will dissolve. The iron 3 will gain, becoming iron 2. The iron 3 will decrease. And this will increase with the passage of time. So, if this one is going to gain, this one is losing, the electron flow is again to this side. So, this one is positive. This one is negative. I'm making it very dirty, but I think it's full. I agree that it's dirty, but it's complete. So it's gaining electron, it's losing electron. The electron are moving toward the positive, they are negative. So this one is negative, this one is positive. So can you construct the equation? Yes, it will go in the forward, it will go in the backward. And what you are supposed to do? Multiply this with 2. Look. Fe3 plus gain 2 electron, making what? 2 Fe2 plus 0.77 volt. The copper will flip copper 2 plus 2 electron, and this become what? 0.34 volt. The electron cancelled. So 2 Fe3 plus copper making what? 2 Fe2 plus copper 2 plus, and the sum is how much? It's 3, it's 4 point plus 0.43 is the E cell, the potential difference. Now, you can do all these questions. What is written? A fully labeled diagram for the apparatus in which you can use standard hydrogen electrode with zinc. Perfect. One side is what? Zinc. And it is what? Zn2 plus 1 mole per dm cube. And the other is what? Standard hydrogen electrode, platinum. This is hydrogen gas. At how much pressure? 1 atmospheric pressure. This is what? H plus aqueous. 1 mole per dm cube. And both are connected by what? Salt bridge and voltmeter. Right, 298. And look at this. Another question. Exactly the same way you need to do the practice. These are the mark scheme. See? This is standard hydrogen electrode. This is copper iron, iron 3, iron 2. Look, these are the marking point. You need to write everything. Platinum or graphite electrode for the iron, but in this one, the copper itself is the electrode. This is the one I did right now. This is for the zinc, yes. Look how they are making. Zinc metal, zinc ion, the salt bridge, the voltmeter, and hydrogen. Take it in, not out. Hydrogen is coming in, yes, of course. You're drawing, you're not showing the function. So hydrogen ion, platinum electrode, 298, like a fully labeled diagram is required. I hope you understand. In the next lecture, I'm going to do the practice. Look, this is my line of action. We know how to construct the half cells and the full cell, and now in the next lecture I will go for what? Construction of equation, right? And I think I will deliver 2 lectures for this, like this is very important area. And then Nernst equation and then electrolysis. Okay, see you in the next lecture, and you are supposed to share, like, and subscribe my channel. Okay, Allah Hafiz.